All right, so as I said, this week we'll kind of split it into two sections. Today will be totally separate from everything else we do. Okay, and today we're going to focus on area of a triangle. So I'm going to come back to this diagram, but I'm going to need this to do something in a second. And basically all it is a triangle, okay, where I've labeled two of the sides. I labeled the upper left side as A, and I labeled the base as B. Then what I did is I put a dotted line going straight down from the top to the base. And by doing that, what kind of triangle did I create? Actually, I created two of them. Yeah, I created two right triangles. Okay, the one I'm going to focus on in a minute is right there. Okay, so I'll come back and I'll do something with that in a second. Okay, but first of all, what we're going to be doing is looking at the area of a triangle. Now there's a basic formula that you learn in geometry. And does anybody remember what that is? Area of a triangle? Yeah, Travis?
Is it half base times height?
Yeah, it's 1/2 base times the height. Good. And that formula works fine as long as you know the two things he just said. If you know the base and you know the height. But if I gave you a problem like that, find the area of the triangle, and I told you one side is 8, the other side is 6, and the angle is 30 degrees. Well, 1/2 base times height, that formula doesn't have a spot to utilize that information. Okay, so we're going to come up with a different formula that's going to allow me to plug those numbers in. Okay, so if you've got a triangle where you don't know the height, right, you need a different formula. Okay, and here's a diagram of a triangle where you don't know the height in example 2a. Yeah, I don't know the height. Now I'm going to use that diagram I had up above to help me figure out a new formula. Okay, and it's going to be based on the old formula. Only one thing is going to change. Just that. I'm going to keep the 1/2. I'm going to keep the B. I'm just going to change the H. All right, so let's kind of look at example 1 and look at what they're giving you there and how we can use that to help us. They're giving you this. They're giving you B. And they're giving you that angle. They're not giving you the height. A is not the height. That's like kind of slanted going up the side. Okay. Does anybody remember what trig function, either sine, cosine, or tangent, I could use that would involve, let me circle the three things that I'm going to work with. Okay, they're giving me A. I want to find H. And they're also going to give me gamma. They're giving me B, but I don't want to circle it because I don't want to confuse you right now, but they are giving me B as well. But I want you to focus on the three things that I circled. What's the name of the side that's farthest away from the angle?
Opposite.
That's opposite. And what about the name of the side across from the 90?
Hypotenuse.
That's your hypotenuse. Okay, so does anybody remember what trig function involves opposite over hypotenuse? Sine. Yep. So I'm going to write down exactly what I just said. Sine of my angle, which is gamma, equals opposite over hypotenuse, h over a. Okay, now what I want to do is I want a formula for h. So I want to put a on the other side. Okay, so how would I move a to the other side?
Multiply.
Yeah, multiply by
A.
A. Yeah, just multiply by A. That's gone. Multiply by A. And there's a formula for your height. Okay, so what I'm going to do is I'm going to plug A sine gamma. Okay, that's what I just found the height equals. I'm going to plug that in right there for the height. Leave the 1/2 and leave the B. And that's going to give me a new formula for the area of the triangle. And it's not going to be 1/2 base times height. It's going to be 1/2 base times A sine gamma. Okay, so let's plug that in. So area is 1/2 the base times A sine gamma. Any question on where this A sine gamma came from based on the triangle up above? So you can write the formula that way, that's fine, but a lot of times what they'll do in the book is they put it in alphabetical order. So instead of writing 1/2 B times A, they write 1/2 A times B. It doesn't matter. Okay, it's the same thing. Okay? And there's a version of this formula that you can use with any two sides. Okay, let me draw just a generic triangle. Okay, so I'm going to put A, B, C. Alpha would be across from A, beta across from B, and gamma across from C. Okay. Look at sides A and B in that triangle, and look at gamma. Where is gamma compared to sides A and B?
Across from my partners.
Well, we don't know that it's a 90, so we don't know for sure that we have a hypotenuse here. But where is gamma in terms of sides A and B?
In between.
In between. Okay, that's the key. You have two sides you're multiplying together with a 1/2, and then it's the sine of the angle in between the two sides. So if I gave you that version, area equals 1/2 B times C, what angle do you think I would use here? The fish. And what's the name of that one? Alpha. Okay. B and C are your sides, and the fish is the angle between them. Alpha. All right, and how about if you wanted to use sides A and C? Yes, the beta. Okay. So the idea is right here. Okay, and if you can remember this idea, then you don't have to memorize three separate formulas. The area of the triangle is 1/2 the product of two sides times the sine of the angle between them. 1/2 the product of two sides times the sine of the angle between the two sides. And now, everything else we do today is based on that one formula. I could teach you just this formula, and you could do every problem in the homework. You don't need anything else. The reason I'm going to show you another formula is because it's faster. Right? This is fast for certain situations. This formula is going to be very fast to do this problem. It's going to be very fast to do this one. It's not so fast to do that one. And when we get to it, maybe you can see what's different about what's given here versus here and here. Okay? But this idea will work perfect as long as you're given two sides and the angle between them. And it'll be fast. Okay, so any questions on the general idea? All right, so let's try this one. Okay, so they're telling me A is 8, B is 6, gamma is 30. Okay, so Tyler, if I look at the information that's given and look at my 3 versions of the formula, which version am I going to use here?
First one.
Yeah, I know A, I know B, and I know gamma. Okay, all I have to do is take what they give me, plug it in, and that's it. So the area of this triangle is 1/2 A times B times the sine of gamma. Hey, now just do that out. Generally, if you get a decimal, we'll round it to 2 places. If you don't, then you don't have to worry about rounding. All right, so Jake, as I multiply straight across, what do I get when I do this first part out? Yeah, 1/2 of 8 is 4. 4 times 6, 24. Okay, now at this point, I'm going to use my calculator to figure out what's 24 times the sine of 30. And sine of 30, remember, any angle that's a multiple of 30, you are going to get a nice answer here. Okay, if it was like sine of 36, that wouldn't be a nice answer. But this one will be. Okay, and anything I want to be careful about before I hit enter?
Radians.
Yeah, I'm in radians. All the problems that didn't have an angle this week are degrees. Okay, so I get exactly 12. Now, what does that 12 represent? It's the what of the triangle?
Area.
It's the area. So what kind of units do you use with area? Yeah. So just put 12 square units. Okay, if you have a problem where they tell you the units, you could put square inches or square feet, whatever it happens to be. But if they don't tell you the units, just put exactly what I did there. Okay, so any question on example 1? Okay, what's different about example 2? Besides, they gave you a picture. What makes that different than how they gave me the information in example 1?
They don't tell us the sides.
You don't know which side is which. So when we do example 2a, I can't ask you which version of the formula are you using. You're never going to know which version of the formula you're using. This time you're using the idea. You're not using a specific formula. Okay, so anyone think they can just set up the formula to find the area here? And the next one, we're not going to use 30 again. I'm just using 30 because it'll give you a nice answer. But I'll do a messier answer in a second.
So it would be 1/2 times 3 times 4 times sine.
Yep. So 3 times 4 is 12, and 1/2 of 12 is 6. And based on the last problem, anyone think they know what 6 sine 30 is? 3. And what would be the units?
Inches squared.
Yep, so 3 square inches. Hey, any questions on that one? All right. So next one, I've changed the angle. This time it's not going to come out to a nice answer, so I've just asked you to round to 2 decimal places. All right. So Francis, can you start me off and tell me what the formula for my area would be?
A equals 1/2 times 5 plus 20
times sine 20. Okay, so perfect. Half the product of the two sides times the sine of the angle between them. Any questions on the setup? Okay, now we'll type it in, but if we can do a little bit of it in our head, we can start it. Brendan, what's 5 times 2? And then half of that? 5. Okay, and it says round, so I'm going to put the symbol. That means I rounded it off. 5 sine 20. Okay, people who tried typing that in, did anyone else get 1.71?
Yeah.
Yep. Okay. Now I'm going to scroll up just to check if they gave me any units. Okay, I don't see any. So I'm just going to put square units. Okay, any questions on that? Okay, so that's the easiest type of problem. Okay, they give you all the information you need directly. You just have to type it in as long as you know this formula. But even if you forgot this formula, you could figure it out doing what we did right here every time. You would know A, you would know gamma. You could find the height by hand every time. Okay? Which is really kind of what you're doing anyway. Okay? It's just hidden in the formula. Okay? But you're really drawing a right triangle like that every time. All right. So I think I showed you this earlier. What's different here? You don't have any angles. So we can't use the formula we had before unless we can find an angle. Okay. If we know all the sides, can we find an angle in the triangle? What do you think? Yeah. So that'd be like if I said solve the triangle. Okay. You're given all the sides. That's a side-side-side triangle. When we practiced solving triangles like this, we had two laws. Anybody remember the names of the two laws? Law of what? Yeah, law of sine and law of cosines. Okay. People remember those vaguely? A little bit? Okay. So one of those two laws can help us to solve a side-side-side triangle. Does anybody remember which law we use? What is it? Yeah, we use cosine, law of cosines. Now there's 3 versions of the law of cosines, depending on if you want to find alpha, beta, or gamma. It doesn't matter which one we find. Just, you need one of them. Pick any one you want. Right? So Eden, which angle do you want to find? Beta, gamma, or alpha?
Gamma.
Gamma. Okay, so we're going to find gamma. And I'm going to write down the law of cosines that enables us to do what you just said. It starts out c squared equals a squared plus b squared. And does anyone remember what comes next? It's minus
2 times
yep,
AB
ab,
sine gamma.
a cosine, because it's law of cosines. And then cosine gamma. Perfect. All right. So fill in your 3 sides into that formula and see what you get. All right. So c is 5. So what's 5 squared? And then 8 squared and 16 squared. Yeah, 16. Now minus 2 times 8 times 4. So 2 times 8 is 16, and 16 times 4. That's 16 times 2. 16 times 4. 64. Okay, we've got some like terms we can combine. 64 and 16. And if I add those two, I would get, yep, 80. And And this is the spot where sometimes people make a mistake. They try to subtract 64 from 80, but you can't, because 64 is multiplied by cosine. So what do I have to do at this step?
Subtract 80 from both sides.
Yep. Subtract 80. Okay, and then, let's see, 25 minus 80. Double check, but I think that's negative 55. Now I can do something with the negative 64 to get that on the other side. Okay, how do we move the negative 64?
Divide it.
Yep, divide it. So that's going to cancel the 64s, the negatives, and the other negatives. Don't do 55 divided by 64, just leave it. In fact, I'm never going to do that. I don't care what 55 divided by 64 is. I care about what gamma is. So that's the cosine of gamma. So how would you get rid of cosine? Yeah. Inverse cosine. So take the inverse cosine of what's on the right. Take what's on the left and plug that into inverse cosine. And that's your answer for gamma. Second, inverse cosine of 55 over 64. Remember, with this law, if the bigger number is not in the bottom, don't even type it in. Just stop. Okay, because if the bigger number ends up in the top, it's going to give you an error. Okay, I've got the bigger number in the bottom, so it looks reasonable. And I got an angle of 30.75. And that's approximate. Okay, so now I've got my angle. And I've got my two sides. So the formula, 1/2 the product of the two sides times the sine of the angle between them. Type it in just like you did before. 1/2. Can somebody remind me, what were the two sides between this angle?
8.
Thank you. So that's half the two sides times the sine of the angle. Okay, 8 times 4 is how much? 32. And then half of 32? 16. Now I'll type into my calculator 16 times the sine of 30.75. So if I did that correct, you should have gotten about 8.18. Okay, anyone else get 8.18? A couple of people? Okay. Okay, so that's the area. Just scroll back up and see if they gave you units to work with. Yes, they did. So that's 8.18. Yep. So put your label. And there's your area. Okay, so overall not bad. Okay, it's the same formula, but you did have to find one of the angles and use law of cosines. So if you'd have to do that every single time, there must be a shortcut. So you don't have to use the law of cosines. Okay, and there is. Okay. If you don't want to learn this formula, you don't have to. You can do exactly what we just did. And just do that and you're all set. If you want a shortcut, instead of having to do the law of cosines, you'd want to use what's called Heron's formula. Now, the first formula I gave you, I showed you where it came from. This one I'm not going to show you. The proof of this one is it's pretty complicated. Okay, so I'm just going to give you the formula and either use it or don't and do it the way we did the last example. Okay, but I'm going to show you how to use this because I think it is faster than the last example. So it says Heron's formula equals the square root of s times s minus a times s minus b times s minus c. Now there's some letters up there, you should know what they are. But then there's some other letters we haven't seen before. What letter up there are people kind of unsure about? We haven't used it. S. We haven't used S before. Does anybody know what S stands for?
Silent.
Well, A, B, and C are going to be the sides, but that's a good guess. Yeah. S is it's a very simple idea, but if you didn't know it, it's kind of hard to guess what it is. What do you call it when you add up all the sides on a shape? And what is that specifically?
The perimeter.
It's the perimeter. S is what we call the semi-perimeter. Okay, it's half of the perimeter. Okay, and you'll never be given the semi-perimeter. They'll give you A, B, and C. You add them all up and then divide by 2. That's the semi-perimeter. So if you remember it as sum, that's actually a good way. Because to find the perimeter, you have to sum, but then don't forget to divide by 2. And now that last problem we did, you could go back and do it again with this problem, with this formula, probably a lot faster. Okay? But I'm not going to do the same problem. Okay, does everyone have Heron's formula? All right, so let's, I'm going to change these numbers a little bit. Let's do, what did we do last time? 485. All right. Let's do, let's see, would that work? Because I can't pick any numbers. Any two sides have to add up to be bigger than the third side. So, yep, that looks fine. All right, so I know A, I know B, I know C. I'm missing S. Okay, Travis, how do I find the semi-perimeter? What do I have to do?
You add all the things together and then you times them by a half.
Yeah, add them all up or divide it by 2. Same thing. Okay, so if we add this up,
23.
8 and 5 gives me 13, plus 10 gives me 23, and half of 23 is how much? Yep, 11.5. It's fine if you do a decimal or a fraction if you wanted to leave it as 23 over 2. I'm going to do the decimal. Okay, so let's find the area. Okay. What's the first thing, Corey, that I put in my formula?
S.
Yep, and S here is?
1/2. Or is it that whole thing?
It's that calculation, but simplified.
11.5.
11 and a half, yep. So that's S. Okay, and Francis, what comes next?
You do S times A, or is it S minus?
Minus.
Minus A.
So S minus, yep, 8. Okay, how about Jake? What's going to come next?
11.5 minus 10.
It doesn't really matter the order you do it in, but I'm going to do that one last. Just because that's S minus C, and I'll do S minus B here. You're going to multiply it all together, so really it doesn't matter. Okay, before I multiply it, there's a couple pieces of arithmetic I can do out. Okay, what's 11 and a half minus 8? Yeah, Eden? 3.5. Okay, Haley, what's 11 and a half minus 5?
6.5.
Yep, 6.5. And Shannon, what's 11 and a half minus 10?
1.5.
1.5. Okay, now I need a calculator. So it's going to be the square root of, and let's just multiply all that together. All right, so we got 11.5 times 3.5, 6.5, and 1.5. So it's the square root of okay, so just take the square root of that. And we get about, let's round to 2, 19.81. Okay, so 19.81. And did they give me any units? No. Square units. Okay, if you don't like Heron's formula, do it with law of cosines instead. You'll get the same thing. Okay, any question on Heron's formula there? All right, let's see. Before you write example 5, just because I'm not sure if we're going to do it or not, what's the difference between example 4 and example 5, besides the fact they gave me a picture? What's different? Yeah.
Numbers.
Okay, the numbers are different. Actually, I just picked numbers, so only.
They don't label the sides.
Yeah, we don't know what side is A, what side is B, and what side is C. So how can I use that formula if I don't know which side is which? Okay, but does it matter where I put A, B, and C? Why not? Yeah, you have to do S minus every side. And it doesn't matter, and I said when Jake gave me the answer, it doesn't matter which one you do first. You got to do S minus A, S minus B, and S minus C. So label them any way you want. You'll get the same answer. Okay, so is there any questions on how you would do this one? Anyone need me to go through it? What's the one thing you'd have to find first that's not given to you? You'd have to find S. Okay, so you'd start with your semi-perimeter, find that, and then fill in your formula. Okay, so that's Heron's formula. Works really well when you know all the sides. What are some special triangles that could come up that we could have to find the area of? Some that we give a special name to. Yeah, equilateral. There's also isosceles. And what's special about, let's do an equilateral. What's special about that? Everything's the same. All the sides are the same. So that means if all the sides are the same, we could use Heron's formula, but we could shorten it because we don't have to have 3 different sets of parentheses. They're all the same. Okay? So I'm going to go through, we're going to look at this triangle and see if we can take Heron's formula and shorten it for this special case. Okay, and we could come up with a formula for an isosceles triangle. We could spend all day doing formulas of for the area of a triangle. But this will be the last one that we do for area of a triangle. Okay, so let's say I call the bottom side, I mean, you could call it anything you want. Let's call it A. What does that mean these other 2 sides would be? They would both be A and A. So every side is the same. What's the perimeter of that triangle?
AQ. Oh wait, you can add them.
You add them, yep.
80, right?
How much?
80.
So that's what all the angles add up to, but I'm asking, how long are all the sides if you add them up?
A plus A plus A.
A plus A plus A, which is
3A.
3A. Okay, that's your perimeter. And now what do I do to that number to turn it into the semi-perimeter? Take half of it. There's my semi-perimeter. And here are my three sides. Plug that into Heron's formula. Area equals. Okay. What's the first thing I put in Heron's formula? Yeah, 3 over 2. A, that's my semi-perimeter. It doesn't matter if you put the A in front or you put the A in the top. We've had this discussion with like the imaginary number I. It doesn't matter where you put the letter. I just like it in front. So I'm going to put S minus something, S minus something else, and just squeeze it in here, S minus the last one. What should I put in my first set of parentheses? S minus A. And the second one? And the third one? A. They're all the same.
Can you just cube the first one so that
You could write it as cubed, but there's going to be an even shorter way. I'm going to show you the formula is going to be even simpler than that. Okay, so there's no number in front of any of those A's, but what is there but it's invisible?
a 1?
Yeah, so it's 3 halves A minus 1A, 3 halves A minus 1A, and minus 1A. Let's just, for a second, let's do 3 divided by 2. It's 1.5. Okay. So what's 1.5A? Take away 1A. 0.5A. Okay. Or you could just write a half. And then what's 1.5A? Take away A again. 0.5A. And again, 1.5A. Take away A. That's another 0.5A. Now, if you read what it says here, it says 3 halves times A times a half times A times a half times A times a half times A. Does it matter the order I multiply things in? No. I could multiply, there's 8 things here. 1, 2, 3, 4, 5, 6, 7, 8. I could multiply them in any order. So what I'm going to do is write them like this. 3 halves times a half times a half times a half. I'm going to put all my numbers up front. I'm going to put all the A's at the end. That's exactly the same thing as what I had up above, just in a different order. Now to do your fractions, just multiply straight across the top. What's 3 times 1 times 1 times 1? 3. And what's 2 times 2 times 2 times 2? 16. And now, I think somebody kind of did this earlier when I asked about the perimeter. What's A times A times A times A? That's A to the 4th. Okay, and there's 2 things there that will simplify a little bit. I'm going to separate the number from the letter. Okay, and you can do that, and we do that all the time when we have something like this. You separate a square root into like square root of 4 times square root of 3. Okay? I'm just breaking it apart into 2. Okay, that's what I just did. Let's look at that second part. What's the square root of A to the 4th? Yeah. What times itself gives you A to the 4th? A squared times A squared. And now the first part, you have the square root of a fraction. Well, you can break that up even more and take the square root of the top and the bottom separate. And which one of those square roots will actually, it'll just disappear? The one on the bottom. What's the square root of 16? 4. So I get a square root of 3 in the top. I have an A squared in the top. and I have a 4 in the bottom. Okay, and the way that you usually see this formula written, so there's no confusion about whether or not the a squared is under the square root, is they put it in front. I don't care which way you write it. That's the formula for the area of an equilateral triangle, where A is the length of the side. Now, which formula do you think is more useful? The one that I have on the board right now, or the previous two that I showed you?
Yes, too.
Why? I agree. This one's not as useful.
I feel like this one was a little drawn out. You know, we had to do a lot of work just to figure out the answer.
But now that we have it, we'd never have to do that again. So now you've got this formula. You can put it on your reference sheet and you're good. So you'd never have to do the work again for it. So we did have to do a little bit of work to get it, but now we have it. So now that we have it, is it as useful as the other two? What do we think?
No, because it's still only able to be used for equilateral triangles. So.
Right. This can only be used for an equilateral triangle. The other two formulas that I gave you before, you can use them on any triangle. This one is only for an equilateral. But it is fast. It's a very fast formula. Okay? You just have one thing to plug in for, and then multiply by the square root of 3, divide by 4, and you're done. Okay? If you don't want to use it, you don't have to. Use Heron's formula. And if you don't want to use that, you don't even have to use that. Go back to the very first formula I showed you. Okay? But this will be faster if I give you a problem like this. Okay, so find the area of an equilateral triangle with side lengths of 8. Okay, so what would my setup be to find the formula here? What would be in the top of the fraction?
8 squared,
Yep. Times,
square root of 3,
and what's in the bottom?
4.
Done. That's the answer. If they wanted it reduced, you could type it in and you could get a decimal if they asked for it. So that's 64 times square root of 3, and then divide by 4. It's about 27.71. And they did not tell me what my units were. I don't know what they are, so square units. So even though it did take a little bit of work to get this formula, it's probably one of the fastest ones to use now that we have it, but it only works on equilaterals. So. And there's a separate formula for isosceles, but I mean, at what point, you got enough formulas, so I would stick with one of the first two, or this one in a special case. Okay, any questions on that? So that's the first half of the test. Okay, there'll probably be 3 or 4 questions of the first formula, 3 or 4 questions of Heron's formula, including maybe one of this type that you can do a little shorter, or go back and use Heron's formula. Okay, I'm not going to care how you do it. All right, so the last thing I'm going to do is just kind of show you a preview of like one of the type of problems we're going to look at this week, just to kind of get you thinking about it. Okay, so the big difference here with trig identities is forget about numbers. Okay, there are no numbers. You don't need a calculator to do any of this. Okay, it's all trig functions. Okay, and to show you a very, very simple identity, okay, I'm going to go back to something we learned on the unit circle. Okay, when we did unit circle, we had to find a coordinate, and we said that sine was equal to one of those letters, cosine was equal to the other letter, and then tangent was a fraction. Does anybody remember what letter sine was equal to out of those two? It's a letter. It's equal to a letter. So it was a definition. Yeah, sine was equal to y. Yep. And what about cosine?
X.
Cosine was x. And what about tangent? It was y over x. Okay, and I want to look at this last one. Okay, everyone agrees or trusts that tangent is y over x? Okay. So what did we just say earlier that y was? Y is the same as sine. And what's x? Cosine. So what does that third thing mean? What have I really just written there, but I didn't write it directly? I said tangent equals y over x. And then I said y over x equals sine over cosine.
Sine over cosine equals tangent.
Yes. That's a trig identity. If you want to take the tangent of anything, you could take the sine of that thing and divide it by the cosine. Okay, so for example, someone give me any number. 6. Okay, I'm just going to show you that this works specifically for the angle 6. Okay, normally you don't do this, but I'll just show you. There's the sine of 6, and I'm going to divide by the cosine of 6. I did sine divided by cosine. Now, according to my formula, that should be the same as doing what?
The tangent of 6.
The tangent of 6. And it is. Okay? That's a trig identity. So those are the kinds of things we spend the rest of the week on. Here's another one. Somebody give me a different angle. I could use 6. 37? Okay, I'm going to take the sine of 37. I'm going to square it. And I'm going to take the cosine of 37. I'm going to square it. And I'm going to add the two together. And watch what happens. I get 1. Okay, give me a different angle. Let's just see if that was a coincidence or if it happens again.
584.5.
584.5.
Yes.
Okay. Well, I'm going on the edge here. 584.5. I'm going to square it. I'm going to take the cosine of 584.5. I'm going to square it. You just like that number?
You said give you any numbers.
Yeah, I did. Yeah, I got what I asked for. And I get 1. That doesn't matter. That's another identity we'll talk about. You can take the sine of any angle and square it, plus the cosine of the same angle and square it. You'll always get 1 as the answer. All right. We won't talk about this one tomorrow, but we will do that one. Okay, so that's the idea of trig identities. It's basically formulas. Okay? But we won't look at it in specific cases. Like I'm not going to ask you for numbers. We're going to do it just like this. This would work for any number. I showed it to you for 6. I did 37 or something like that. It would work for any angle that you want it to work for. Okay? But the point is to figure out that this is the same as that. Okay? That's what you have to figure out. Okay, so any questions on that? All right, so I'm going to give you guys a little time to start the homework. You get a little over 15 minutes. Okay, so on 280, I want you to try 6 to 16, just the evens. 20, 22, and 33. Okay, I'm giving you a hint for number 33. Okay, they want you to find what I shaded in blue. And the only way to do it is to find what I have shaded in red, find what I have shaded in green, and subtract the two from each other. Does that kind of make sense? Like if you take what's in red and you subtract what's in green, you'd be left with what's in blue. Does that idea make sense?
What page is it, Mr. Hager?
That's page 280. Okay, I'm not telling you how to find what's in red and how to find what's in green, but that's the concept. Find the area of the red portion, find the area of the green portion, and subtract them. And you'll be left with what's in blue. Okay, my hint, well, to find the area of what's in green, you learned how to do that today. To find the area of what's in red, there was a formula we did way back second day of class for area of a sector. Okay, it starts out A equals, and then there's a formula. Okay, so if you look back in your notes for week 1, you'll find how to do the area of this red section. And today you learned how to do the area of the green section. And you just have to subtract the two results. Okay, so that's a hint for number 33.